Today we will be discussing Lab 4, Oscillations. In this lab, we will be observing a spring mass system, or in other words, a mass oscillating vertically on a spring. We will understand how we can implement Newton's second law and the energy principle to predict the motion of the mass as well as the forces acting on it. We will be using Tracker, and we can observe the system experimentally from here. We will edit a starter code using initial conditions and physics principles and obtain data predicting the motion of the object. Comparing these models, we can compare and contrast the accuracy of our experiment as well as inquire the physics concepts involved. We begin by using Tracker to calibrate and fix the origin towards the spring and the mass. Then we can plot the x and y coordinates and put them in a CSV file to use for later. Now that we have our experimental data, we can form our predicted data using GlowScript. Setting our initial conditions, such as the ball's mass and the initial position vector from the tracker data, we can also solve for the K constant, the stiffness of the spring. We do this by using the equation the period of oscillation equals 2 pi times the square root of the mass divided by the constant. Rearranging, we can solve for the stiffness constant. We can talk about how the period of oscillation is calculated later on. We can also calculate the relaxed length of the spring, using the force of gravity equaling the force of spring. Rearranging this, we also solve for this and set the initial conditions in the GlowScript. Moving forward in the code, we set up initial conditions to computate the spring force. In addition to this, we understand that the system energies include the kinetic energy, gravitational potential energy, and spring potential energy. We can calculate these energies and solve for total energy as well by adding them all together. Using Newton's second law, we can update the velocity and position of the mass as well, after calculating F net, which in turn would be F spring plus F grav, the spring force plus the gravitational force. Using this, we can update both of these things. We can update the energy as well, using physics principles that we understand. Because no energy is transferred in this experiment, we can also assume that the total energy should equal 0. Hence, later on, we'll find out if the energy change supports the law of conservation of energy. Now that our code is set up, we can run the code. Doing this, we must choose a file that holds our CSV data file. Once we choose it, the code will automatically graph the change in energy as well as observed versus predicted. Here we can see the plot of observed versus predicted given from the GlowScript code. We can see that it's very off. This may be from the tracker, as well as the calibration, or the video, or other changes that might be incorporated, such as forces and energies that we have not accounted for. The other graph given by the GlowScript code is the energy change model. Here we can see the change in total energy, kinetic energy, gravitational energy, and spring force energy. Given by the key, we can look at how each energy is affected in the concept of time. We can conclude that looking at this energy graph, we are able to see that for every positive energy there is an equal negative. This allows the total sum of energy change to equal 0 as predicted. The law of conservation of energy is upheld, and no energy was transferred in and out of the system. Earlier, when discussing how to calculate the stiffness constant, we were required to calculate the period of oscillation. We can do this by observing both the tracker X and Y position data in time.